So what we're looking at is exercise 155, number 9, 10, and 11. So number 9 is say an equilateral triangle has an altitude of 18.7 centimeters. Find the length of the equal sides. So equilateral triangle means a triangle where all the sides are equal in length and all the angles are equal. If all the angles are equal, it means each one of the angles are 60 degrees. So the altitude will be the line that falls from the apex straight down at 90 degrees. That is what the altitude is. So that line that I drew there is the altitude. And they told us that the altitude is 18.7 centimeters. So this is 18.7 centimeters, that altitude there. Right? Which will be from there to there. That's 18.7 centimeters. So how are we going to find the length of the equal sides? How are we going to find the length of the equal sides? Well, we know that all of the angles are 60 degrees. Right? That's one of the main things. And we also know that the side which represents the altitude in the triangle created is 18.7 centimeters. So let's label it up to make it easy to see. So let's call here A, B, C, D. So we have a triangle, we have that triangle labeled out. So let's say we were looking at the triangle A, B, C. Let's look at the triangle A, B, C. As a matter of fact, let's pull it out so we could see it a little better. Let's call here A. Let's call here B. Let's call here C. So that will be the triangle ABC if we extract it out of that equilateral triangle. And we know this length here is 18.7 centimeters. Okay? And we know this angle here is 60 degrees. So therefore, if we have to find the length of the equal sides will be AB, DB, and DA. All of them will have the same length. So if we were to find the length of AB, then that would be the length that represents the length of all the equal sides. Good? Now AB in our situation here is the side that is opposite to the right angle, and therefore AB is the hypotenuse. What we have is a side that is opposite to the angle that we are considering, which is the 60 degrees. And therefore this side here, AC, is the opposite side. So we ask ourselves, what connects what we want to find, which is AB, or the hypotenuse, to what we have already, which is the opposite and has a value of 18.7 centimeters. Which ratio out of sine, cosine, and tan connects opposite and hypotenuse? And if we evaluate SO, CA, TOA, which is the acronym that helps us remember the relationships and the ratios, we'll see that the SO component, which is sine, is opposite over hypotenuse, is the only one that relates opposite and hypotenuse. So we'll use that one. So we'll say sine theta is equal to opposite over hypotenuse. Opposite over hypotenuse. In this case, theta is 60. So we could write that sine 60 degrees will be equal to opposite, which is 18.7, over hypotenuse, which is what we want to find, AB. Okay? So if we put sine 60 over 1 and we cross multiply, we will get that 18.7 by 1 will be equal to AB multiplied by sine 60, or sine 60 by AB. So if we do that multiplication there, which is the cross multiplication, we could write that AB sine 60, AB sine 60 degrees, when you multiply them, will be 18.7. So therefore, if we want to get AB, we could easily find AB by saying AB will be equal to 18.7 divided by sine 60. Okay, and if we plug that into our calculator, we'll be able to get what AB is. If you plug that in the calculator, you'll be able to find it. So check it and see. So if we round it off to 1 decimal place, we'll get AB is equal to 21.6 centimeters to 1 decimal place, or 1 dp. Okay, so we are now looking at exercise 155, number 10. And in this one, they said, find the altitude of an isosceles triangle whose vertex angle is 38 degrees and whose equal sides are 7.9 meters long. So they would like us to find the altitude. The altitude in this example will be a vertical line that comes straight down and touches the base at that point. That is the altitude. It's at 90 degrees, and this is the length they want us to find, or the height. So let us label the triangle A, B, C, and use the properties that we know for an isosceles triangle to help us. And one of the properties is, if we know the apex angle, then we can work out what the two base angles are, right? Because we know that they'll be equal, first of all. So if we call each one of those base angles theta, then we could find the value of theta. Having found the value of theta and knowing one side of the triangle, we could find the altitude. So let us also label this point here, where the altitude intersects AC. Let us call that point D, so we can also talk about it. So what we'll say is that 38 degrees plus theta plus theta must be equal to 180 degrees. And that is simply because the angles in a triangle are supplementary. The angles in a triangle are supplementary. So that's why we can make this statement, and therefore 38 plus 2 theta will be equal to 180 degrees. So therefore 2 theta will be equal to 180 degrees minus 38 degrees, and therefore theta will be equal to 180 degrees minus 38 degrees divided by 2. When you evaluate that, you should get 71 degrees. Okay, so theta would be equal to 71 degrees. So now, if we know what theta is, if we extract a triangle, or we look at the triangle BDC, I'll extract it here so you could see it by itself. And we have B here, we have D here, and we have C, and this is a right angle, BDC. Then we know BC is 7.9 meters. We know the angle located at C is 71 degrees. And we have to find BD. BD will be opposite to that 71 degrees. And 7.9 meters, which is BC, will be opposite to the 90 degree, which means this is hypotenuse. So we have to ask ourselves which ratio out of sine, cosine, and tan connects what we want to find, which is the opposite side, BD, to what we know already, which is BC, or hypotenuse. And the only one that comes back is sine, because sine is opposite over hypotenuse. So we'll use that relationship. We'll say sine theta is equal to opposite over hypotenuse, which means that sine of 71 degrees will be equal to opposite, which is BD, over hypotenuse, which is 7.9 meters. So that implies then that in order to find BD, what we'll do, we will put sine 71 degrees over 1, and we'll cross multiply. BD by 1 will give us BD, and that will be equal to sine 71 degrees by 7.9, which is the same thing as saying 7.9 sine 71 degrees. So therefore, from this, we could calculate what BD will be equal to. Simply put that into your calculator. So if you work that out, you will find that you will get 7.5 in this case it will be 7.5 meters. So BD will be 7.5 meters. And that will be the answer that you're looking for. So you're now looking at exercise 155, number 11. I say the equal sides of an isosceles triangle are each 27 centimeters long. So these two sides will be the same length, 27 centimeters long, and the altitude is 19 centimeters. So the altitude is shown there. Find the angles of the triangle. So we say, if we label it A, B, C, and we call this point here D, then we know that these two angles here will be the same, theta, those will be the base angles, and the angle at the top, if we call that alpha, that will be the apex angle. Now we could find angle theta by isolating the triangle ACD, for example. So if we isolate that triangle ACD, so we call here A, here C, and here D, we'll have angle theta. We'll have 27 centimeters as the length AC, and we'll have 19 centimeters as the length AD. So how would we go about finding this angle here? Right, that angle theta. That angle theta could be found by observing that the 19 centimeters is opposite to the angle that we want to find. and the 27 centimeters, which is AC, will be opposite to the right angle. And therefore, this will be the hypotenuse. That will be the hypotenuse. So, once we identify opposite and hypotenuse as the items that we know, we ask ourselves which ratio connects opposite and hypotenuse, and the only ratio is sine. So we say sine theta will be opposite over hypotenuse. In this case, sine theta will be equal to, opposite in this case is AD, and that is 19 centimeters, over hypotenuse in this case is AC, which is 27 centimeters. So therefore, if sine theta is equal to 19 centimeters over 27 centimeters, the centimeters will cancel out. We could say that to get theta, we'd have to use the inverse sine function. So we say sine inverse, or sine to the minus 1 of 19 over 27. And that will give us what we want to find. So if you go to your calculator and you punch that in, you should get the answer. So you should find that you get 44.7 degrees. Of course, being careful and mindful that your calculator has to be in the degree mode when you're doing this calculation. Right? So this will be to 1 decimal place. Okay, and that will be your answer. Now, having reached this point, have we answered the question that they asked us? This is just one answer, because they asked us in that question, find the angles of the triangle. Are all the angles equal to theta? No, because in an isosceles triangle, only the base angles are equal. So we now know two angles. We know the two base angles, but we still have to find the apex angle. So theta will be equal to 44.7 degrees, and this will be equal to the value of the angles at the base, or the base angles. However, we still have to find alpha, and that's not a problem, because we know that if we take alpha and we add 2 theta, 1, 2, we must get 180 degrees. And that's simply because the angles in a triangle are supplementary. So what we have to do now is substitute what we know, which is theta, and solve for alpha. So we could write from here that alpha plus 2 times 44.7 will be equal to 180 degrees. So alpha will be equal to 180 degrees minus 2 times 44.7. Okay? Minus on both sides. So we'll get the answer for alpha by doing that calculation. So when you evaluate that, you should get 90.6 degrees, and that is again correct to 1 decimal place. So you always put down what your accuracy is to 1 decimal place. Okay, so the topic we're looking at is angles of elevation and depression. And the first note is the angle formed by a person's horizontal line of sight. The angle formed by a person's horizontal line of sight and his inclined line of sight is called the angle of elevation. The angle formed by a person's horizontal line of sight and his inclined line of sight is called the angle of elevation. Okay, so on the board, what you're seeing here is a person standing and his initial line of sight is horizontal. He's looking horizontally across. Now, if he were to see some object on top here, let's say a bird flying, he would have to raise his gaze from the horizontal line of sight all the way up to see the bird. And the angle that his eyes would have to traverse or move through to see the bird from his horizontal line of sight is known as his angle of elevation. Okay, so that is important because it always starts, the angle always starts from his horizontal line of sight, which is critical. Okay, so that first note covered the angle of elevation. This note will cover what is the angle of depression. And it goes like this. You're writing the angle formed by a person's the angle formed by a person's the angle formed by a person's horizontal line of sight the angle formed by a person's horizontal line of sight and his declined line of sight and his declined line of sight is called the angle of depression. Is called the angle of depression. So in this diagram here, this person initially is looking horizontally out and he sees some object on the floor. So what he would have to do is to drop his horizontal line of sight downwards through an angle called the angle of depression, so that his declined line of sight now is now affording him the ability to see whatever is on the ground. So the angle of depression would be that angle between the horizontal line of sight and his declined line of sight. There's a note here, and the note is that both of these angles, that is the angle of elevation and of angle of depression, both of these angles are always less than 90 degrees. Both of these angles, that is the angle of elevation and the angle of depression, are always less than 90 degrees, i.e. they are acute angles, i.e. that is, they are acute angles. So we'll be looking at a couple examples now, and our first example, you write it, first example. First example, the angle of elevation of the top of a vertical tree, the angle of elevation of the top of a vertical tree from a man standing on level ground, 25 meters from the base of the tree, 25 meters from the base of the tree is 38.5 degrees. Is 38.5 degrees. Full stop. Calculate, full stop. Calculate the height of the tree. Calculate the height of the tree correct to the nearest meter. Calculate the height of the tree correct to the nearest meter. So I'll just read it over quickly. The angle of depression of the top of a vertical tree from a man standing on level ground, 25 meters from the base of the tree, is 38.5 degrees. Full stop. Calculate the height of the tree correct to the nearest meter. So the first thing that we have to do here is to come up with a diagram that represents the information that has been given to us. And what we say is the angle of elevation of the top of a vertical tree from a man standing on level ground 25 meters from the base of the tree is 38.5 degrees. So what we'll do, we come up with the tree first of all. That's the tree. And this is the base of the tree right here. And 25 meters away from that base of the tree is the man. The man is standing 25 meters from the base of the tree. And what they said is the angle of elevation of the top of that tree from the man who is standing on level ground with the tree is 25 meters away. So we could put in the 25 meters now, because the man is 25 meters away from the base of the tree, and the angle of elevation is 38.5 degrees, which means that because they didn't give us the height of the man, we'll assume that the man is more or less in line with the base of the tree, his gaze, his eyes. They didn't give us his height, so we'd have to assume that for practical purposes, he's more or less, his height is negligible, and therefore his gaze will be, as his horizontal line of sight will be in alignment or along the level of the ground. And it's from there now, you will measure your angle of elevation, which would be the height he would have to raise his gaze through to see the top of that tree there. So this angle here, that you'd have to raise his gaze from to that point, will be the angle of elevation, which is 38.5 degrees. So this angle in here will be 38.5 degrees. That will be the angle of elevation. Having gotten that now, of course, they said it was a vertical tree, and if he's standing on level or horizontal ground, then the angle between the vertical tree and the horizontal ground will be 90 degrees. So this position here is the ground, which we say is horizontal ground. We let B represent the base of the tree. We let T represent the top of the tree. All right, and we let X represent the position of the man. So in that way, we would come up with a diagram that represents the information they give you. The critical point here is that the man's height is negligible, so he would be more or less on the level ground. Then what we have to do is calculate the height of the tree. In this diagram, the height of the tree will be TB, and that will be opposite to the angle 38.5 degrees. So this here will be opposite. So we want to find opposite. What have they given us? What information have they given us? They gave us the angle, and they also gave us the length XB, which represents the distance from the man to the base of the tree. Relative to this angle, 38.5 degrees, the length or the distance XB is adjacent. This is adjacent here. So, we want to find opposite, and we know adjacent. So we ask ourselves, out of sine, cosine, and tan, which one relates opposite and adjacent? So if we go back to SOHCAHTOA, we'll see that the only one out of sine, cosine, and tan that relates opposite, which is what we want to find, and adjacent, which is what we know, is tangent, because tangent is opposite over adjacent. It's the only one out of these three. Sine doesn't relate opposite and adjacent. Cosine does not relate opposite and adjacent. Only tangent does. So this is the ratio, the trigonometric ratio we will use. So we write tan theta will be opposite over adjacent. In this case, opposite was TB and adjacent was XB. So we could therefore say tan of 38.5 degrees will be equal to TB, which is unknown, over XB, which is 25 meters. So if we place tan 38.5 over 1 and cross multiply, TB multiplied by 1 will be equal to tan 38.5 multiplied by 25. So we could say that TB by 1, which is TB, will be equal to 25 tan 38.5. So therefore, we could work out what TB is by going to our calculator and punching in those figures. We'll get 19.886 if we go to 3 decimal places. And if we want to round it off to the nearest meter, as they had said, which is what we have to do, we have to give them what they want, we'll have to put it equal to 20 meters correct to the nearest meter. correct to the nearest meter. Example 2 says, a girl 1 meter tall, a girl 1 meter tall, standing on top of a vertical building, a girl 1 meter tall, standing on top of a vertical building, 45 meters high, 45 meters high, sees a car some distance away. A girl 1 meter tall, standing on top of a vertical building, 45 meters high, sees a car some distance away. When the angle of depression is 55 degrees. Is 55 degrees. How far away is the car from the base of the building? How far away is the car from the base of the building? So in example 2, we are told that a girl is 1 meter tall. This person is 1 meter tall, and she stands on top of a vertical building. So let's say we have our vertical building. Right, that's our building. And the girl is standing on top of that building. So let's say this is the girl here on top of the building. Okay, so the girl on top of the building. And we know that this girl is 1 meter tall. So if we draw a line from here, another line from there, we know that that height there is 1 meter. They also told us that the vertical building is 45 meters tall. So we could also indicate the height of the vertical building here as 45 meters. Okay, so we know now if this is 45 and that is 1, we could pull a line further across, and we could say now that the distance between the top of the girl's head and the bottom there will be 46 meters, because 1 and 45 will make 46 meters. But they told us that this girl who is standing on top of the building, right, the building, she sees a car some distance away when the angle of depression is 55 degrees. So let's say this is the horizontal pathway here, and she's going to look to see a car somewhere along that path. But let us assume, because of her height relative to the building, that her line of sight horizontally is initially at the top of her head here, because we cannot differentiate her eyes from the top of her head. They didn't give us that small detail, so we'll assume that her horizontal line of sight is horizontally out like this. And the reason why we need to establish that horizontal line of sight is because the angle of elevation and the angle of depression is always relative to the horizontal line of sight. Remember we spoke about that? We made special notes about that. So this is where you have to always start from. You always have to start from the horizontal line of sight. So this here is the horizontal line of sight. And it's the horizontal line of sight of the girl. And she's going to drop her gaze, her horizontal line of sight, to some value. by some angle. She's on the building looking out this way, right? She's looking out. And then she sees something there, so she has to drop her gaze down to look at it. Good? So she has to move this downwards. Okay, and how far downwards? Well, it depends on what she's going to look at and how far it is. So let's say she's looking at something at that distance there, because they say she has to look at the car. So there's the car here that she's looking at. That's the car. And the angle she would have had to drop her gaze by, that angle shown is the angle of depression, so that you would see along this line the car. This here is the angle of depression. So this is the rationale that we go about getting the angle of depression, and in this case it was 55 degrees. So those people who had the angle at the base, that is why I was asking you, how did you deduce that the angle was down here, or wherever you had it on the ground? Right? And the idea here is that we always have to take it relative to the horizontal line of sight. But in this position, it's a bit challenging for this angle to help us do a calculation. So what you tend to do now is to use the other properties of angles and lines that you learned, like corresponding angles, alternates, and so on, to help you to get an angle that would allow you to work out the question, which is how far away is the car from the base of the building. That would be the distance from here to here. That'll be that distance. Okay? So if we were to call here T for top, B for bottom, this would be a right angle because it's a building and a horizontal ground. This here will be the ground here. All right, if we name the car, we say the car is located at position X, so that'll be okay there too. Then what we could say, there are two ways we could do it. We could get this angle in here by subtracting it from 90, right? The angle here, you could get it by subtracting from 90. Or what you could do is observe that there is a special Z here. And that special Z will enable us to locate an angle. So for that practice, we could say, if we observe this special Z here, which is this horizontal line of sight, this line that comes down here, and then this horizontal line here, then we observe that there's a special Z going on there, this horizontal ground here. That special Z means that this angle here and this angle down here are alternate angles. And alternate angles are equal. So it means that the angle at X is also 55 degrees. Now once we establish that this is 55 degrees, then we could start to do some working. So what we'd do, we'd say relative to this angle, this 55 here, this side that we want to find is adjacent. Okay? And what are we given? In that triangle TBX, what are we given? We are given, or we know, that side there, where the entire length, or height, sorry, is 46 meters. So we know TB is 46 meters, which will be our opposite. So TB on this side is opposite in this diagram. So we ask ourselves, what connects what we want to find, which is adjacent, to what we know, which is opposite? And the only sign, the only ratio, trigonometric ratio, that connects opposite to adjacent, which is what we know to what we want to find, is tangent. So you write tan theta is equal to opposite over adjacent. In this case, theta will be 55 degrees, so we could write tan 55 degrees will be equal to opposite, which in this case is TB over adjacent, which is BX. that really means that tan 55 degrees is equal to 46 meters over bx. So if we put tan 55 over 1 and cross multiply, we will get that 46 is equal to bx tan 55 degrees. What we did, we multiply 46 by 1 and we multiply tan 55 by bx and we put them equal. So therefore we could find that 46 divided by tan 55 degrees, if we divide by tan 55 degrees on both sides, we'll get 46 over tan 55 degrees is equal to bx. And if we work 46 divided by tan 55, if we work that out, we'll get 32.2 meters if we round it off to one decimal place or to 3 significant figures. So this will be correct to 1 decimal place, and that will be the answer that they're looking for. How far away is the car from the base of the building? And if x represents the position of the car here, then the distance from the building, the base of the building, bx, is 32.2 meters to 1 decimal place. So that will be the answer right there. Okay, so we have a third example. Example 3. Example 3. It says, a surveyor stands 100 meters from the base of a tower. A surveyor, S-U-R-V-E-Y-O-R, that's S-U-R-V-E-Y-O-R, a surveyor stands 100 meters from the base of a tower. On which an aerial stands. On which an aerial stands. Full stop. He measures the angle of elevation. He measures the angle of elevation to the top and bottom of the aerial as 55 degrees and 51 degrees as 55 degrees and 51 degrees respectively. Find the height of the aerial. Find the height of the aerial. So I'll call it back. Read it back over now. A surveyor stands 100 meters from the base of a tower on which an aerial stands. Aerial is A-E-R-I-A-L. Full stop. He measures the angle of elevation to the top and bottom of the aerial as 55 degrees and 51 degrees respectively. Full stop. Find the height of the aerial. Find the height of the aerial. Okay, so in example 3, you say if surveyor stands 100 meters from the base of a tower on which an aerial stands. So if you represent the tower, right, what a tower look like? A tower would be something like this. Right? The tower they're talking about is like those electricity towers, right? where you see like a crisscross grid, right, to make up the tower. That's the tower. And the surveyor is standing 100 meters from that tower on which an aerial stands. An aerial is a piece of tin metal that is used to transmit or receive a signal. That's what an aerial is. So an aerial will just simply be something like that. That's an aerial. A thin piece of metal standing up. Right? So there's your tower, and that's your aerial there. He measures the angle of elevation to the top and bottom of the aerial. Now let's draw the surveyor, because the surveyor is really 100 meters from there. So let's put the surveyor at this location here. Let's just say the surveyor here is a man, right? So the man is located at that point, and this here will be the base of the tower. Okay? And this surveyor now is going to be looking at two positions. He's going to be looking at the top and bottom of the aerial. So let's say he's looking at the bottom of the aerial. That will be his line of sight to be able to look at that bottom of the aerial, not so? Because this is where he is initially, and they didn't give us a height for him, so we'll assume that his horizontal line of sight will be along the line of the ground. And then this here will be his inclined line of sight to see the bottom of the aerial. Good? Then in order to see the top of the aerial, he'll have to carry his gaze a little higher to see the top of the aerial. So let's say that is his gaze to see the top of the aerial. In order to get from his horizontal line of sight to the bottom, to see the bottom, he must go through that angle there, because he starts off at horizontal and he goes through this angle so that he will see the bottom of the aerial. In order to see the top, he starts off horizontally looking in this direction, and he has to go through this angle to see the top of the aerial. That makes sense? Right? He's looking here initially, and then to get to see the bottom, he has to go from here to here, and then to see the top part, he has to go from here to here. Okay? So let's do a little labeling to make it a little clearer. Let's call, so this here is the aerial. Okay, this will be the top of the aerial here. And this here is the tower. Okay, so hopefully that will help you a little more. Find the height of the aerial. So they want us to find this height here. This is the height they want us to find, the height of the aerial. How are we going to do that? This is the height of the tower. And this here is the total or combined height of the two of them. So let us do some labeling. If we call here T, here A, right, you already labeled the bottom of the tower B, and where the man is C. Let us say that the height of the aerial will be from T to A. So we could write that TA, which is what we want to find, the height of the aerial, that could be found by saying TA is equal to TB minus AB. TB, if I find TB, which is this whole length here, and I find AB, and I minus AB from TB, I'll get the height of the aerial, which is TA. Okay, so we'll do it in parts. Let us find TB first. So to find TB, I'll draw the triangle that we'll use to find TB. We're going to find TB first. Then we'll find AB, and when we subtract them, we'll get the height of the area. So we'll find TB first. And to find TB, I'm going to use the triangle TBC. That's the triangle I'm going to use. I know that a surveyor stands 100 meters from the base. So B to C will be 100 meters. Right? That's this distance here. I know that that will be 100 meters. Good? So I'm going to use that here, 100 meters. And I know certain things. We didn't put in the angles. Let's put in the angles. He measures the angles of elevation to the top and bottom of the aerial as 55 degrees and 51 respectively. If you look at these two angles, the smaller angle must be the smaller angle they gave us here, which is 51 degrees. So I'll put that here. Even without understanding the word respectively, just looking at the two, I can't put 55 here and 51 there. It wouldn't be correct, right? The smaller angle is the 51 and the larger angle will be the 55 degrees. Okay, that'll be the one that goes to the top. So in our triangle here, TBC, the larger angle will be applicable because that's going to the line TC. So this angle here will have to be the larger one, which will be 55 degrees. So I'm going to find TB by noting that we have adjacent and we want to find opposite. Okay? And therefore we have to use tan, because tan is the only one that relates opposite and adjacent. So tan theta is equal to opposite over adjacent. So therefore tan of 55 degrees will be equal to opposite, which is TB, over adjacent, which is BC, and BC is 100 meters. So if we cross multiply, we will see that TB will be equal to 100 multiplied by tan 55 degrees. And therefore we could find what TB is. TB works out to be 100 multiplied by tan 55, which gives you 142.8. Right? I mean, that's if we round it off to one decimal place. So we go into one decimal place. Okay, so we now know TB. So if we found TB, all we have to do now is find AB, and we'll be able to find TA. So let us find AB now by looking at a specific triangle. Let's look at the triangle that includes AB in it. It will be the triangle ABC. So let's use ABC, and we'll use that to solve for AB. In this triangle, the angle at C, which will be going to AC, will be the 51 degree angle. Right, so that's the angle we'll use. We know BC is still 100 meters. And we want to find AB. So we'll use the fact that AB is opposite and BC is adjacent. And we know that the ratio that connects opposite to adjacent, that is what we want to find, so what we know is tan. So we'll use tan again. Tan theta is opposite over adjacent. So in this case, tan of 51 degrees now will be equal to opposite, which is AB, over adjacent, which is BC, 100 meters. So if we put tan 51 over 1 and cross multiply, AB by 1 will give us AB, and that will be equal to 100 by tan 51. And 100 multiplied by tan 51 will give us 123.5 meters. And that will be correct. 123.5 meters, that'll be to 1 decimal place. Okay? So now that we have TB, right, we worked out what TB was, and we worked out what AB was, right, there's AB. We could find out what TA is, which is the height of the aerial. TA is the height of the aerial. So we simply find, therefore, TA, which is equal to the height of the aerial, will be equal to TB, which is 142.8, minus AB, which is 123.5. And that will give us the answer they're looking for, which is 19.3 meters. And that will be the answer. 19.3 meters will be the answer to 1 decimal place. And that will be our answer. Okay, so our answer is 19.3 meters, right, to 1 decimal place.